Bill, let me throw it back to you. Take us back to Gwinnett County. Tell us a little bit about Water Environment and Reuse Foundation Project 1511. This is entitled Demonstration of High Quality Drinking Water Production Using Multi-Stage Ozone Biological Filtration, a comparison of DPR with existing IPR practice. And this is a really interesting project because it has the potential to help utilities dealing with tricky surface water source dynamics by using direct potable reuse. So spell it out for us, if you would.
Okay. As Jim mentioned, the Gwinnett pilot plant has the ability to blend in DPR water directly from their advanced wastewater treatment plant. And we can compare that side by side with their current IPR treatment at the drinking water plant. We're looking at blending ratios of IPR and DPR water, looking at water quality and operational performance with these different ratios of blended water. So we started at 0% DPR, which is just using the IPR water from Lake Lanier, and proved that we matched up to the full-scale facility. And then we switched to 50% DPR, so it was a 50-50 blend. And we will also be testing 25% and 100%, meaning all DPR water. This is relevant to Gwinnett County because the lake quality changes through the season, and changes in temperature plus shifts in organics impact the ozone demand and filter effluent turbidity. We want to find out if mixing in DPR water in these tricky transitional times, such as a lake turnover, by doing a 50-50 blend, can we smooth the operations and maintain water quality during these lake turnover events. So the data, we show a little bit here just to whet your appetite. The slide on the left shows how ozone demand jumped abruptly by deepening of the epilimnion following the start of a lake turnover event. And on the slide to the left, if you look at the red line labeled lake turnover start, just to the right of that, you can see how the yellow dots really jumped up, a real abrupt change. And that's really hard to treat at their plant when the ozone demand jumps like that. But the blue dots, the 50-50 blend, they were so dampened by that blend, it didn't really jump much at all. And that showed in the average ozone demand, which you see in the numbers under the graph on the left, and it also showed in the filter head loss accumulation rates. That graph is pretty apparent. If you look at the slide on the right, head loss accumulation rate in foot per hour, the DPR filters, the two on the left there, had much lower head loss accumulation rates than the two IPR filters on the right. And that's because when the ozone demand jumped, they had to adjust coagulant doses to keep down turbidity, you know, because it's a drinking water plant. We got to keep turbidity low. So that has significant ramifications. And when the head loss accumulation rate jumps up, it's very hard for them treatment-wise. So we invited their operators down to see the pilot plant, and they were quite impressed at how the DPR water made treatment operations easier.
Yeah, that is fascinating, and I understand you guys are still crunching the numbers on this, so you're still doing the data analysis.
Yeah, that's right. It's still underway, but the data looks promising, and we think it'll prove out as shown in these graphs.